Hello, class. Welcome to the next segment in the week 6 material. And in this segment, we're going to take a look at what actually is going on with the parentheses of the functions that we create in Python and how we can actually use this idea of use this idea surrounding the parentheses to make our functions a little bit more useful. And this will kind of get into the more practical side of creating functions. Usually is a good idea to create functions if you have a whole bunch of really complicated stuff that you want to really simplify down. And one of the examples I like to use is, say, evaluating the cosine of a number. If you want to evaluate the cosine of a number, then you have to use what's referred to as a Taylor polynomial, which it basically involves evaluating dozens to hundreds of different algebraic terms, which is just really complicated. And if you can distill that down to something like, I'll go and demonstrate on the screen here really quickly. If you can distill evaluating the cosine down to something like this is so much easier and so much simpler to work with. In fact, when we talk about the stuff that's contained within the math module, which will be a couple segments later on, it's really nice to have such a much simpler thing that we can type out into Python rather than having to worry about running that Taylor series expansion algorithm over and over and over again anytime we want to take the cosine of a number. But if we use a function, we can take really, really complicated things like evaluating the cosine of a number and distill it down to something that's much simpler to work with and much easier to work with. But before we even get to that point, we do need to talk about how you can actually pass information to a function or give values to a function to actually do something with. And that's where we're going to actually resolve what's going on within the parentheses here. So you'll see that I have a similar function to what we had earlier, and this function is called add. And again, Spider makes this really easy because the name of the function itself is bolded here. And then you'll also notice that I have the parentheses, and then you see I have what look like two variables here, and they're separated by a comma. And this actually is how a function can keep track of the information that is given to it. Because if you skip down to what we see on line 7 here, you see I have the command to tell a function to run. Again, just simply type the name of the function, parentheses, and you'll also notice that especially on both or on all the lines here, 7, 8, and 9, you'll notice how when I have the parentheses here, I also have two values contained within the parentheses, and those values are separated by commas here. So what this is going to enable us to do is this allows us to pass specific information to our function. The function will then do something with that information and give us back some sort of result. In fact, that's usually the basic process for a function. You pass some values or you pass some numerical entries or whatever it might be. You pass some sort of information to the function does something with it, and then gives you back some sort of result. So in this case, on line 7 here, we're telling this function add to run, and we're going to pass the number 2 to the first entry, or that'll be the first parameter in the function. Sometimes these are also referred to as arguments. The second number, again, we know which is which because they're separated by commas. The second value, which is the number 2, gets passed to the second value in the function. And the way that the computer can keep these numbers separate and keep track of them is by what's on the variables that we've set aside here. So in this case on line 7, this number 2 will be passed to this variable x, and this number 2 will be passed to this variable y. And you'll see here on line 3, I'm actually using the variables x and y. And again, the way that the computer keeps track of that information, keeps track of the information that I give to the function or that I pass to the function, is by these variables x, y. So the first number here goes into x, the second number here goes into y. And then here on line 3, I'm saying take that value of x, take that value of y, simply add those two numbers together to get this result on the right hand side, which then goes in this variable called the sum. And then here on line 4, we're telling the computer to print out that exact expression. The value of x plus the value of y is equal to whatever. So in the case on what's on line 7 here, we take this 2, that goes into x, take this 2, that goes into y. We add those two numbers together to get a result, and then we print out what the result is. And then same idea here on line 8. So here we're passing this number 1 to x. X will be holding on to 1. And this number 5 will go to y, but it'll do the same exact thing just with two different values that were passed to it. It'll add those two numbers together, get a result, and print out the result. And again, same idea here on line 9, except here the number 9 goes into x, the number 8 goes into y. We add those two numbers together to get a result, and it'll print out that result. So you can see how we repeat the same general algorithm or the same general list of commands, just with separate values. That is the specific values that we want to give to the function. In this case, we're just doing something really simple here, primarily for illustrative purposes. So here we're just having the computer add two numbers together. So, and we're using that, we're using a function to accomplish that. So here we're just simply taking 2 and 2, put those together or add those together, 1 and 5, add those together, and then 9 and 8, add those together. But it's basically repeating the same exact task, just with different values that were fed to the function. And if we want to see what this actually looks like, so it's going to run this first, then it's going to run this, and then it's going to run what's on line 9 here, just going in order like any other program. Now, if we want to see what this result actually looks like, we can go ahead and run this, and you can see our program does in fact give us the result that we wanted. 2 plus 2 is 4, 1 plus 5 is 6, and 9 plus 8 is 17. Now, something else that's kind of important to keep in mind, in the case of a function that adds two numbers, this isn't as important, but in general, for any given function, this is something that's very important to keep in mind, and that is the order here matters. So here my first number was 1 and the first value was 5, and that corresponds to what goes in x and what goes in y. So if I were to reverse these, so now the 5 appears first and the 1 appears second, and again the individual entries are still separated by a comma here, the 5 would now go into x and the 1 would now go into y. Now, in the case of adding two numbers together, this is pretty much inconsequential, but in general, you do want to pay close attention to the order of the parameters that get passed to the function, because sometimes you might be dealing with a function that, say, takes a list and then a number, or a string and then a number, and you want to make sure that you have the order correct, otherwise the computer is not going to be able to do much with that. But that also kind of leads into another neat little point. The values that you pass to the function can be anything at all, as long as the function is able to actually do something intelligible with them. So I could also pass strings to the function that we have here. So this would take the string 2, and this would take the string 2. This would go into x, and this would go into y. And instead of adding those together in a mathematical standpoint, since these are strings, and again, we know they're strings because of the quotation marks here, instead of adding those two things together, it will actually perform a concatenation and join those two strings together, again, in the order that they appear in this equation here. So here, so in this first call here, on line 7, x and y will be assuming values that are strings, and the second and third call, they will be assuming values that are in fact numerical. But if we want to see what that looks like, you can see 2 plus 2, it doesn't add those together mathematically since these are strings, it just performs a concatenation and just joins them together in the order that they appear. But here 2, the string 2 goes into x, this string goes into y. This right here will be interpreted as joining those two entries together in the order that they appear, a simple concatenation operation, and then simply printing out what the result is. And another thing that might be worth bringing up is the number of function, or the number of parameters that you have in the parentheses up here must match the number of values that you pass to the function itself. So here I have a function that's set up to take in two values, again, x and y, but if I try to pass 3 values to a function that's expecting 2 values, then you will get an error message that looks like this. The function name takes 2 positional arguments, but 3 were given. Basically means that you put too much in you put too many parameters into the function. And also it's possible to put too few parameters into a function, and that will have an error message that looks like this. Function name is missing 1 required positional argument, and it'll tell you which variable up here in the function header is in fact left without a value. Now, there's nothing special about this function that I have here. So there's nothing special about the name of the function. So instead of calling this add, I could also call this do math. So the fact that I called it add has no bearing on what the function itself actually does. So I could just say, call it do math, and it will still do the exact same thing that we had before, as long as I'm consistent with the variable names. So you can see it still reproduces the same exact output that I had before. And similarly, I could also change this function to subtract, even though the function itself is actually adding two numbers. But again, this is not struct, that's something else. I almost did it again. For some reason, my fingers really want to type the word struct. So now we have the function called subtract, which is deceptively named because it's still adding two numbers here, and that's what's given on line 3 here. So it doesn't really matter what you call the function. The fact that you call it something like add doesn't itself mean the computer will actually add stuff together. The actual process, the actual commands that you want the computer to run will determine what the function actually does, and that's what's going on here on lines 3 and 4. The fact that we have a plus sign between the two parameters that are passed to the function, that's what determined what the function actually does. The fact that this is called subtract is actually pretty much irrelevant. It's just deceptive because we're actually adding two numbers together, but you'll see I get the same exact result. It does not matter what I call this function. That won't affect the operation at all as long as I'm consistent with it. And I really want to emphasize that because that's something that seems to confuse people. They think that the name of the function has some sort of bearing on what the function actually does, and that's not exactly true. What actually gets the function to do some specific task is what goes in the function itself. In this case, these two commands, this one in particular is what's actually causing the computer to add the two numbers together. The fact that this function was called add to begin with is completely inconsequential. That's just how the computer keeps track of what function is which. And I called this add because the name of this function uh, is very self-explanatory on what the function actually does. Again, this kind of goes back to the best practices of naming variables. When you name a variable, it's a good idea to give it a name that also tells you what the variable is holding on to. When you name a function, it's also a good idea to name the function give the function a name that also represents what it's actually doing. And another thing that's very important to note, the variables that are defined within the function are not accessible outside of the function. So if I were to try to do, say after I get done running all this, I could try to do print the result of the sum, and you can see it's giving me an error message. It's saying the sum is not defined. And before you start cussing your computer out and calling it an idiot when you say, what do you mean the sum's not defined? It's defined up here on line 3. And then hopefully you'll remember back to what I said. Whatever variables are defined within functions, that is, whatever variables are defined within the indentations here, or whatever variables are given in the parentheses here, those values are not accessible from outside the function. This print statement is outside the function, so it is not able to access the value of the sum, or this variable, the sum, that was defined on line 3 here. Now, if I take this print statement and put it inside the function, then that is perfectly fine because the sum was defined within the function, and since this print statement's now within the function, that's okay. I take it out of the function, that's not okay because the variable, the sum, was defined in the function. It was declared in the function, and the same rule also holds for these variables x and y. So even if I try to put this print statement after it's done running through all the functions, I will still get the same error message saying x is not defined. So now you might be wondering, is there a way we can actually get information out of the function? And the answer is yes, and that'll actually be a question that we answer in the next segment. So with that, I will see you all in the next segment.